Good morning, students. Let us study today series feedback amplifier. This consists of the function generator Vs, input resistance Ri, and then we have the gain into voltage, output resistance R0. It is a feedback amplifier, so output is I0 is fed back to the input. So we'll be having the feedback voltage here as Vf with the polarity plus and minus. The feedback voltage is plus minus and the current I0 is given through here. Now this part is named as A circuit and this part is named as B circuit. And this A circuit is called as unilateral open loop amplifier. And this is the feedback network. The A circuit is named as the open loop amplifier. And the B circuit here named as beta circuit. And it is named as the feedback network. I'll repeat. The function generator Vs is connected and we will be having here Ri as input resistance and R0 as output resistance. We'll be having gain into the voltage. Output current here is I0. I0 is fed back in terms of beta I0 and we get the voltage, feedback voltage as Vf with the polarity plus here and then the minus. And the A circuit has an input resistance Ri and output resistance R0. Our beta circuit samples the short circuit output current I0. It samples the current I0 and provides the feedback voltage Vf. I'll just write down here. Our beta circuit samples the I0 and provides the feedback voltage Vf. These all points you should write. It is very simple. See, the first line is what? Our series. This is series part. Even this is series part. Series feedback amplifier consists of function generator, resistance, input resistance, gain into the voltage, and then the output current I0, whatever we get here, it is fed back through beta I0 part and we get the feedback voltage Vf. This is our first point. Now A circuit is named as open loop amplifier and the beta circuit is named as feedback network. Our A circuit consists of input resistance Ri, output resistance R0 and A into V. Our beta circuit consists of beta into I0 where the I0 is fed back through the beta circuit and we get the feedback voltage Vf. Here beta circuit samples the output current I0 and gives the feedback voltage Vf. Beta circuit provides zero resistance to the output loop and then does not load the A circuit. It does not load the A circuit or the open loop amplifier circuit. It provides a zero resistance, so it does not load the A circuit. And here also the feedback signal Vf is equals to beta into I0. Whatever we get here, Vf is equals to beta into I0 is an ideal voltage source. Thus the beta circuit does not load the amplifier input. Amplifier circuit. I'll just repeat the points. This is the block diagram of series feedback network. It has A circuit, beta circuit. A circuit is named as open loop amplifier. Beta circuit is named as the feedback network. A circuit has Ri, R0, AV, and the beta circuit has beta I0, where we get the feedback voltage. And here our beta circuit samples the output current I0 and gives the feedback voltage as Vf. And the beta circuit provides the zero resistance to the output loop and does not load the A circuit. Here the beta signal, here beta circuit, we get through beta circuit we get Vf is equals to beta I0 is an ideal voltage source. Thus beta circuit does not load the amplifier circuit. Now few more we'll find out here the closed loop voltage gain. The closed loop voltage gain AF. The closed loop voltage gain AF. Closed loop voltage gain AF. How we did in the previous class. Same fashion. The closed loop voltage gain. We know that the voltage gain is output divided by the input. We all know that gain is output divided by the input. Here for series feedback amplifier, the output is I0 and the input is Vs. Or it is written as A divided by 1 plus A into beta. I'll repeat once again. We are finding the closed loop voltage gain. Gain becomes output divided by the input. Gain is output divided by the input. For this block diagram, the output is current I0 and the input is Vs. So we write I0 upon Vs. Now, here our aim is to find out the RIF and ROF. What is RIF? RIF is the input feedback resistance and ROF is the output feedback resistance. Now we'll see how we'll find the input feedback resistance. Here RIF is given as Vs divided by II. Means at this point we are finding RIF, input feedback resistance is Vs divided by the current here is II. Or it can be written as Vs divided by Vi divided by Ri. Or it can be written as Ri into Vs divided by Vi. Or Ri into Vs can be written as, this voltage can be written as Vi plus beta AVI divided by Vi. How we get this Vs? Vs is equals to how much? Vs is equals to how much? Vi, this Vi plus our beta I0, and I0 is how much? AVI. I0 is how much? AVI. So we will be writing Vs as Vi plus beta I0. I0 is AVI. Or if I take the common here as Ri, Vi, if I take the common, it becomes 1 plus A beta divided by Vi. So we'll be having Ri into bracket 1 plus A beta is input feedback resistance. This is the expression for RIF. Now to find the ROF. How we find the ROF? Output feedback resistance. ROF is named as output feedback resistance. Here we know that Vi is equals to minus Vf. Now from this diagram we'll see Vi is equals to minus Vf, and minus Vf is equals to minus beta into I0. And we know that to find the output feedback resistance, we need to make the output current as some test current IT. This is a rule what we have followed in the previous class also. We need to make the output current as some test current as IT. Okay, we need to make the output current as test current as IT to find out the output feedback resistance. And minus Vf is equals to minus beta into I0 and minus beta into IT. Then we'll be writing V is equals to IT minus A into Vi into R0. Substitute for our Vi. So we get IT, Vi from here, beta into IT. If I substitute, plus A beta IT into R0. Or we'll get here IT as common, 1 plus A beta into R naught, or we get ROF, output feedback resistance, as 1 plus A beta into R naught. Means this voltage by current, if we take V upon IT, if we take 1 plus A beta into R naught, this is nothing but ROF. I'll repeat. To find the input feedback resistance, the steps are with respect to this diagram. If we see, RIF becomes Vs divided by II, and II becomes Vi upon Ri. Now we'll find the value of Vs. Vs, we know that it is Vi plus beta into I naught, and I naught is AVI. Like that we simplify and we get RIF is equals to Ri into bracket 1 plus A beta. To find the output feedback resistance, output current I naught should be given as some test current as IT. Then we get Vi is equals to minus Vf. From the diagram we get Vi equal to minus Vf and Vf equal to beta I naught. I naught becomes test current IT. So V becomes IT minus AVI into R naught. At the output side, if we apply, means in this diagram, the output voltage, what we get, which is IT minus AVI into R naught. IT minus AVI into R naught. I'll repeat once again how we got from here. We have got V is equals to I naught minus AVI into R naught, or we have made I naught as test current IT, so AVI into R naught. Vi, we know that it is minus beta into IT. Substitute in that, then what we get here, IT plus A beta into IT into R naught. IT you take as common, then we get 1 plus A beta into R naught. Then this voltage by current, we get 1 plus A beta into R naught. So this is the output feedback resistance, which is equals to 1 plus A beta times R naught. And in this case, the negative feedback increases the output resistance. This should have been expected, since negative feedback tries to make I naught constant in spite of changes in the output voltage, which means increases the output resistance. The voltage sampling reduces the output resistance. Current sampling increases it. If you have any doubt on this topic, you can ask me personally on my WhatsApp number. Thank you.